Question 4. The equation of a curve is y is equal to f of x, where f of x is equal to 2x minus 1, and then the square root of 3x minus 2, then minus 2 here. The following points lie on the curve. Non-exact values have been given, correct to 5 decimal places. These are the points here. And you can see that the x coordinate is increasing. Okay. Then, after that, they are saying that part A, find the value of k. Give your answer correct to 5 decimal places. So, of course, this one is a y coordinate. So, if these points lie on the curve, that means their coordinates must satisfy the equation of that curve. So, the y coordinate here is k, is going to be equal to 2 then times x. So we shall have 2 into the x coordinate is here, that is 2.0001. Then there is minus 1 here, okay? And then at the end of that, this one is supposed to multiply this square root of 3 again times 2.0001. Then there is minus 2 here, and then there is a minus 2 here. So what will this one give us to 5 decimal places? We have 2 into 2.0001 and then minus 1. Then I can close those brackets. Then we have the square root of 3 into 2.0001. Then close, minus 2. Then after that, minus this 2 here. So we get to 5 decimal places. This will be 4.00063. 4.00063, 5 decimal places. Now, if you put 6 to 5 like it was, you lose, because they have stated the degree of accuracy. You have to be very careful when you're rounding off. The table shows gradients of the codes A, B, A, C, A, D, and AF. And these are the gradients. But you can see for AB, this one is 6.2501. Then it keeps on increasing by a smaller unit. It increases. Okay. Now, they are saying find the gradient of the code AE. Give your answer correct to 4 decimal places. Of course, you know that gradient, we get the change in y over the change in x. Okay. Gradient of AE. We need to get those coordinates, the change in y. Let's look at A. We are looking at this one here, then the 4, and then here, then here. So we shall have the y coordinates 4.63566 minus 4. Then we divide by 2.1, then minus the 2. 4.63566 minus 4. Then down we have 2.1 minus 2. So this one gives us 6.3566. 6.3566. And this one was even exact, 4 decimal places. That is that. Then, next, part C, deduce the value. I expected something like this. Deduce the value of f prime of 2 using the values in the table. Now, here, you can look at, of course, f prime of 2. It means the gradient of the function at x is equal to 2. Because you know that where we have f prime of x, this one gives us the gradient function. Then when we put the value of x, that one gives us the gradient, okay, of that curve at that given point. Now, by looking at what we are having up there, let me just do a sketch here. It's like I have a curve here, and then in that curve, there are points here. Okay, let's say this is the point A, which is 2, 4. Okay, now when you look at the coordinates we are having here, the x coordinates are increasing, okay, by a certain unit. They are increasing. Even the y coordinates are increasing. So this simply implies that the coordinates I'm going to have up here, we are having A up to F. So A, let's say we are having B here, we have C here, we have D here, we have E here, and maybe this is F here. Okay, so we are having these lines, the codes from A to B. There is a change in X, there's a change in Y, also there, also there. Then we can also go to E and then to F. You see that? So we can find the gradient of each of these as given. Okay, like that, change in Y, there is change in X, change in Y, then change in X. Okay, we are going to have something like that. But you can see that the gradient, these lines here, when we shift this one and we put it here, the gradient reduces like that, like that. So by the time we rotate this one like this, at A here, that means the change in X would have disappeared. Okay, there is a change in X here. To go to each of these points, there is a change in X. There's a change in X. Okay, so when I keep on dropping from F and then I approach A, that means that change is going to go away. And by the time it goes away, this simply implies that at A here, now this chord would have turned into a tangent at that point. And at that point, the gradient of the tangent and the curve is always equal. Okay, but let us just study what is happening here. At A, I mean, for AB, this is 6.25. Then you go to AC, it is 6.2511. This is 2501, then 11, then something adds on to this to go to 26, and then this one here, the gradient is 6.35, then this one here. So by looking at just these first ones here, 2501, then 2511, you see? So that means the change is so small to move from B to C, okay, from B to C. That means by the time we draw our line to be at A, the gradient has to be this 6.25 because the change now begins from here. When it comes to B, then there is a smaller change that is added. Then C, like that. So it has to be 6.25. So that means F prime of 2. Okay, because 2 is the X coordinate at A. Remember, we have 2, 4. Check back here. You see that? That is at point A. Okay, so at 2, 4, F prime is supposed to be 2.5. So I can maybe say here that I can say moving from F to A, okay, the change in X goes to what? To the 0. So therefore, at A, let me just write this. Thus, at A, the gradient of the tangent, the gradient of the curve equates to that of the tangent, So that is that. Actually, if you can use differentiation, if you can differentiate this one here, okay, if you have peeped into the A-level content and you can be in position to differentiate this one using the, we call it the product rule, then after that you substitute 2, you will automatically get this value here. But this is all what is needed. Whatever I've explained, they don't need any of this. Just write this value. You just need to look at how the values have been changing. How has this one changed to this one here? So you have gone from A to B. There is a small change. 0.0001. Then by the time you go to C, now we are seeing 0.0011, okay? Because this one is still there. So Always look at the first number here. It tells you a lot. So as simple as that.